Hello, I am Prithwish Jana, a MTech second year student of Computer Science and Engineering Department at IIT Kharagpur. In this video, I'll talk about my MTech project on fairness in virtual conference scheduling. This work was done over the last 1 year under the guidance of Professor Nilay Ganguly. COVID-19 pandemic has disrupted all our lives, imposing many restrictions on social gatherings and travel. So conferences in the post-pandemic world have also moved to virtual format. About the motivation, traditionally in physical conferences, all people gather at the same place, the same time zone. So schedule is time zone and venue specific. But virtual conferences require people worldwide from various time zones to connect at the same time. For example, different participants have different conveniences over a day. Further, everyone is not interested similarly. This calls for time zone aware conference schedules. In this line, our goal is to report an optimal scheduling of the conference talks such that worldwide participation is guaranteed. So let's say in a conference, P is the set of participants, T is the set of planned talks, and S is the set of non-overlapping slots, that is time intervals. Assuming a talk to be scheduled only once, a conference schedule gamma is a 1-1 mapping from the set of talks to the set of slots. Our work can be divided into two parts. The first is to develop a multi-stakeholder approach to fair conference scheduling. This work has been published in the main track of ACM Web Conference 2022. We developed an integer linear programming based joint optimization framework to balance efficiency and speaker and participant fairness. The next part on group fairness in virtual conferences has been communicated to the ACM SIGKDD Conference 2022 and is under review. Here, we focused more on the participant side and developed a polynomial time solvable joint optimization. Tested on CVPR or FATRA conferences, our generated schedule were much more fair and can attract more audience than the original schedules. So our approach. Firstly, the interest scores. For each participant talk pair, this is modeled as the probability of satisfaction of a participant if he attends the talk. Secondly, the ease of availability, that is participants can have different time conveniences. So we define three important criteria. The first is participant satisfaction, that is the expected gain of a participant P from a talk T in slot S. It should be the joint probability of interest and availability scores for a participant summed over all talks normalized by his personalized highest cumulative gain. The second criteria is speaker satisfaction. So generally, it can be said that a speaker will be more satisfied if his talk welcomes a large participation. The third criteria is a natural objective for conference organizers, that is to maximize the efficiency, that is the total participation. We solve our efficiency fairness tension by a joint optimization framework and integer linear programming. It maximizes the total expected participation and simultaneously minimizes the unfairness. But integer linear programming is NP hard. To tackle this, we propose two methods to scale up. The first is repeated rounding of fractional solutions. Here, we solve the joint optimization by linear programming first and use heuristics. The second process is to represent participant profiles and perform k-means clustering on them. We also develop another approach of individual fairness, IFairConf. As per Rawlsian justice, we maximize the satisfaction of the worst of agent. The relaxed objective can be mapped to a minimum cost bipartite matching problem, which is polynomial time solvable. So IFairConf is much faster than mFairConf, which was NP hard. Next, group fairness. There may be logical groupings among the participants, time zone based or sensitive attribute based. This results in intergroup disparity. We have proposed two approaches to ensure group fairness. In repetition of events favorable to the worst of groups, we first get the most efficient schedule. So our initial schedule set gamma contains these event time slot pairs. There is a repetition budget B and participants can be divided into disjoint groups. So after this, each time we choose the least satisfied group, then we probe an event time slot pair that best improves the satisfaction of the worst of group. We use a synthetic dataset of 10 talks and 10 participants. We also use Rexit 2017, ICML 2017, and CVPR 2019. These are in an increasing order of conference size. mFairConf is not scalable for large conferences like CVPR, but our polynomial time solvable IFairConf and the group fairness approaches are. Also, the greedy approach is slower than the repetition of events. On the right, we present the results of group fairness through the greedy algorithm for the Rexis and CVPR. It can be observed from the top right table that All baselines either achieves good efficiency or good fairness, but not both. Our greedy approach achieves a good balance between fairness and efficiency. In the bottom right, we have plotted group-wise mean satisfaction for all the groups in an ascending order. The group fairness approach, indicated in blue, achieves a flattened satisfaction curve. These are the references. Also, we have built a full-fledged web application that will generate fair schedules for conferences. So as on date, the website is live at the web address given at the bottom of this slide. Thank you.